Alright, let's continue from the last lecture. In the last video, we learned about the double integrals over the general domains. Well, we actually learned about the rectangular domains too, but that is not our focus because the rectangular domain is quite simple and straightforward when it comes to calculations and understand it. So what is tricky is the general domain, and it's tricky in the way that we need to determine the type, and sometimes it's not so clear what type it is. So this is related to the Fubini's theorem 2 in this slide. So as you can see, the theorem 2 here has two formula, one at the top here and two right here. So which formula to use, this depends on the type of your general domain. If your domain is type 1, you need to apply the first formula. But if your domain is type 2, you need to use the second formula. For the type 1, you need to integrate your function with respect to y first. So you are going to sweep y variable first. But then when you imagine sweeping the y variable, it means that you go along the y-axis. It means that you go vertically. Okay, and when you go vertically, it means that you have to start somewhere and end somewhere. So you have to start at the lower and end at the upper part. So when you look at the integration here, you start at the lower function and you end at g2x. Here is the upper function. In this case, you have to imagine going up and down, right? So you go from the floor to the ceiling right here. Alright, so for that is for type 1. And now for type 2, you need to integrate your function with respect to x first. So sweep x first. But now imagine going in the x direction. It means you go along the x-axis. It means you go horizontally. Right? Horizontally, it means that you go from the left to the right, which means that this h1y here is the left-hand function. This is like the starting point of the sweeping, left-hand function. And you end at the right-hand function or the line, you call that right function. Okay, so we have two formulas, and in order to use this, you need to know the type. And how do you know the type? The only way to know about that is to draw the graph and you determine the type yourself, right? So the key is to draw the graph. So with this, we did some examples last time, and the first one that we see is this example one. I know that we did this already, but I'm gonna spend maybe 1 or 2 minutes about this one. Okay, so with this region, to me, I see this one function at the top here. Okay, like that. And then I see another line down here. Okay, all the way through. So you can see that with these two lines, they trapped a region between them. This enclosed region becomes the base of the double integration and also the volume under the surface. So with this region, if I want to sweep throughout the whole region, I see that I see it that I'm supposed to sweep from the lower function to the upper function like that, lower to upper, lower to upper, lower to upper, and repeat that all the way through the whole region. And you can see that with this kind of sweeping, I can cover the whole region. Okay, and this sweeping y variable, this is sweep vertically, right? So this is type 1, and of course, which means that I need to use formula number 1. Okay, And now some of you might disagree with me. You might say that, hey, I don't see that. What is upper function, lower functions here? I don't see that. I want to try sweep this horizontally. Well, you can try that. It doesn't hurt to do that. So let's try it. You want to sweep horizontally. So start from the left to the right. It has to end here. Start from the left to the right. Left to the right. Now left to the right. All the way through here. Alright, and once we sweep the whole range, well, you can add something here too. You can see two problems here. The first one is this not included. This is not included in your sweeping, so you didn't include it. You didn't cover the whole region, so that is a problem. And the next problem is that in this area, you sweep from one line to the same line. So you basically sweep from black line to the black line. Sweep over same function. If you sweep over same function, it means that when it comes to integration, it's not going to come out well. So that is a problem 1 and 2 in this case. So to compare this with the vertical sweeping, it's going to make more sense to go with the vertical sweeping and the type 1 and the formula 1. For example 2, we did that last time, so I'm not going to go into the details. But if you can recall, we in this case, it's obvious that we are supposed to sweep from the left to the right, and that is type 2. But that is not our main focus here. In this video, we are going to do some more examples, because the best way to understand about this sweeping is through the experience. So let's take a look at example 3 here, which to me is going to be quite different from 1 and 2. 1 and 2 is quite obvious which type the domain is. But for me, in this example 3, it's not so obvious. So we need to choose what type of domain this example 3 is. So let's take a look here. So in this example 3, they ask us to find the volume of the prism. Volume of the prism. You see the word volume. You sort of expect this to be about the double integral. Okay, and volume whose base. So yes, we have a base here is a triangle. And this triangle is bounded by, the first line is x-axis. That is the first line. And then we have the next line, which is y equal to x, and the next line is x equal to 1. So 3 lines are going to create a region for our domain. Now, with the base specified by the problems, we have the top 2. So which is this surface function. So we have this surface function 3 minus x and minus y. That is the top of the volume. So with this information is enough to start with the formulation. So everything is ready here, but the first thing we need to know is to determine which formula to use. And it also means that we need to know which type this domain is. So the best way is to draw the graph. Determine which type by graphing. So that is our starting point. We are going to draw it. So the first line is x-axis. So I'm going to draw it right here. Well, it's drawn for you already, so I'm going to repeat it. X-axis right here. Alright, and then the next line is y equal to x, which is the straight line with the slope of 1 passes through the origin. Right here, and then the next line is x equal to 1, and it's going to be right here. And you can see that 3 lines here trapped a region between them, and this region is the blue region right here. Now we need to determine the type of this region. So some of you look at this and you might say that, hey, I see one function at the top and one function at the bottom. So what some of you might see this line is at the top of the region, and this line is at the base or the bottom of this region. Alright, imagine this one is upper function and the other, the black one, is the lower function. So in this case, we need to sweep from the lower to upper, and all the way through. Okay, so this kind of sweeping, you can see right away, this is vertical sweeping, which means that this is type 1, right? So type 1, let's put the formula here. Integrate of the function we have is 3 minus x minus y, and we are going to integrate this with respect to y first. Well, we do the vertical first, right? So this is y variable. Okay, with respect to y first, from the lower function to the upper function. Okay, and then don't forget to integrate this one more time with respect to x. Well, we have two variables here. It doesn't make sense to integrate this just with respect to y. So with this x, we have to go through all the range of x here, and we can see that x starts from 0 right here and ends at x equal to 1. So let's put 0 and 1. Okay, this upper function, this lower function is g1x, and upper function is g2x. Okay, and you can see from up here that we have the equation for the lines available. So all you need to do is to put that equations in. Well, that is one way to look at this region. Two functions, one lower, one upper. But some of you might not agree with me. And you don't have to agree with me with everything. So some of you might say that I don't see that. I don't agree with you. Instead I see one function on the left hand side, looking like this, and another on the right hand side. Instead of lower and upper, I see, in this case, the same region. I see one on the left and one on the right. And with this kind of looking, we can see that to sweep the region, we need to sweep from the left-hand function to the right-hand function, left-hand function to the right-hand function, all the way through the whole range. Okay, and with this, you can see that this is horizontal sweeping, and this is type 2. And this is x variable first. And you can see that both ways. Well, let's put the formula first. This, we sweep with respect to x variable first, 3 minus x minus y with respect to x first. And we sweep from the left-hand function to the right-hand function. So left-hand function, this is h1y, and the right-hand function is h2y. Okay, and don't forget the second integration with respect to y. And you can see right here that for y, the whole range starts from y equal to 0 and ends at y equal to 1. So let's put that in, 0 to 1. Alright, so in this case, it's possible to look at this region and see type 1, and it's also possible to look at this same region and see type 2. And as you can see by the sweeping, we cover the whole regions both ways. It means that both this region can be both type 1 and type 2, and you can use either the formula 1 or formula 2. So in some problems, in some cases, you are going to run into a situation like this. And you might ask, and then what? How do I decide? In this case, you can go either way. You can pick one and use that one to do the calculation. But in this problem, since we want to compare them, I am going to do both of them, and the result from both of them should come out to be the same. All right. So, but in practice, you can just pick one and work on that. So let's work on the first type. The first type first, and let's see what the answer is. So for the first type, so we have this one function at the top, right here, and another function at the base, right here at the bottom. Okay, and we are going to integrate this with respect to y first, because we are going to sweep this vertically like that. So let's put everything into the formula and do some calculation. So we have this integration of 3 minus x minus y with respect to y first. So we have to put the lower function right here, which is the g1x, and the upper function right here is g2x. Okay, and then we integrate this with respect to x, starting from 0 and to 1. With this, I want you to keep in mind that for the first integration, we are supposed to integrate this with respect to y. We are working on the y variable, and which means that the boundary that we are looking at has to be y value. So what is hidden here is this is y equal to g1x and y equal to g2x. Okay, so all we need to do is to find this g1x and g2x. So let's take a look here. g1x is the lower function. So you can see that here, lower function is this, y equal to 0. So it means that g1x is equal to 0. Now the upper function is right here. So we can see that this is y equal to x. So this is g2x going to be equal to x. This is supposed to be function with respect to x, right? With respect to x. So you are supposed to put x here. Don't put y here. It doesn't make any sense. This doesn't make any sense. Okay. So now we know what to do. So we have this double integration starting from lower function, which is y equal to 0, ends at y equal to x of 3 minus x minus y dy, and then integrate again with respect to x, starting from x equal to 0 to 1. And now when it comes to integration, you know what to do, right? We are integrating with respect to y, so we treat x as a constant. So let's do that. Integrate 3 with respect to y, that's 3y. Integrate x with respect to y, x becomes constant, so this is xy. Integrate y minus y with respect to y, this becomes minus y squared over 2. And we need to evaluate this at two values, y equal to 0 and y equal to x. And don't forget the integration, the rest of the integration, which is integration with respect to x from x equal to 0 to x equal to 1. Okay, let's put all these values in. So x goes into y. This becomes 3x. X go to y. This becomes minus x squared. X goes to y. This becomes x squared over 2. And now I need to subtract this with another value, which is 0 goes in. And you can see that 0 goes in, everything goes to 0. So I don't need to do anything much here. Done. for the first integration. And this is integration from 0 to 1 with respect to x. Well, I'm going to combine this same power. So this is equal to minus 3x squared over 2. Alright, so let's integrate this with respect to x. Should be very easy to you. So 3x, integrate that with respect to x. This become 3x squared over 2, right? And then minus 3x squared over 2 here, integrate. This becomes minus 3 over 2 x cubed over 3. And we need to evaluate this at 0 and 1. So 1 goes in, becomes 3 over 2. And 1 goes in, oh well, we can cancel this, 3. So 1 goes in, this becomes minus 1 over 2. And we also have 0, but 0 goes in, everything goes to 0. So we can see that the answer for this this calculation is 1. And that is when we decide that this is type 1. And I told you before that in this case we can choose this region to be type 2 too. So let's try type 2, whether it's going to come out to be the same number. Alright, so let's try the same example, but instead of type 1, let's do this as a type 2. For type 2, this is going to be different because we are going to sweep the x variable. So we are going to have one function on the left, like this, and another function on the right here. Okay, and we sweep the x variable like that all the way through the whole region. So let's put everything into the formula. So we have this integrate of function, which is 3 minus x minus y, and we want to integrate with respect to x first. Now we have to integrate this from the left hand function, and from the formula this left hand function is h1y and ends at the right hand function, which is the h2y. Okay, and don't forget that this first integration, this is with respect to x. So the boundary has to be x value equal to x equal to. Okay, and then with the double integral, you need the second integration too. So this with respect to y, and y goes from 0 all the way to 1. So 0 to 1. Now you might ask me, what is this function h1 and h2? So let's find that. h1y, this is the function on the left hand side. So it's going to be this black lines here. Right, we need that x equal to y. So h1y is equal to, well, this is a function with this is a function of y, so don't put x here. So this is equal to y. Well, even though this is equal to x too, but do you see that h1 with the parenthesis of y, it means that it has to be represented with y, function of y. So don't put x this in here. Right, so keep it like this. Alright, so now we need the function on the we need h2y. So we have this h2y, and this is supposed to be the function on the right hand side. Okay, and let me check on something Alright, okay, this is h2y. This is the function on the right hand side, which is the red one. So this is x equal to 1. So you can put this right here, x equal to 1, and h2y here is equal to 1. Because both of them has to be equal to x. So now that we know h1y and h2y, we can put everything in the formula and do the calculation. So we have this integration from 0 to y, and from the left hand function, that is x equal to y, to the right hand function, which is x equal to 1. Okay, and the function that we are working on is 3 minus x minus y. We need to differentiate, not differentiate, we need to integrate with respect to x first and then to y. Alright, integrate 3 with respect to x, this becomes 3x. Integrate x, this becomes x squared over 2. Integrate minus y, in this case minus y becomes constant, so this is minus y x. And we need to evaluate this at two values, y and 1. Okay, alright, and don't forget the next integration with respect to y from 0 to 1. So let's plug these numbers in. So this number 1 goes in, this becomes 1 goes in as x, so this becomes 3. 1 goes in as x, this becomes 1 over 2. 1 goes in as x, this becomes minus y. Alright, minus the other term, this y is going to go in as x. Y goes in as x, so this becomes 3y. Y goes in as x, this becomes y squared over 2. Y goes in as x, this becomes minus y squared. Alright, and this whole thing has to be integrated one more time with respect to y from 0 to 1. Alright, this is quite long here, so let's combine them and make it look nicer. So 3 minus 1 over 2, this becomes 5 over 2. Minus y minus 3y, that is minus 4y. Minus, okay, and this whole term, this is minus 3y squared over 2. With the minus sign, it becomes plus 3y squared over 2. And we need to integrate this with respect to y. From 0 to 1 should be easy. This is 5 over 2 y. This minus 2y squared. And integrate the next term with respect to y. You get y cubed over 3, and 3 cancel with the 3 we have here, so this becomes y cubed over 2. Okay, evaluate this from at 0 and at 1. So 1 goes in, this becomes 5 over 2. 1 goes in, this becomes minus 2. 1 goes in, this becomes 1 over 2, and 0 goes in, everything goes to 0. So this, hold on. Okay, I thought I got it wrong. Not wrong. 5 over 2 plus 1 over 2 becomes 3. 3 minus 2, this is 1. Alright. So you can see that in this case, whether you decide this triangle to be type 1 or type 2, it comes out to be the same. The reason it comes out to be the same is because when you look at the sweeping, whether you sweep vertically or horizontally, you sweep through the whole region just the same. So that's why it works for both types. Sometimes if you sweep certain way and it doesn't sweep through the whole region, then you have to avoid that. In this case, it works both ways, so that's great. It's sort of like lucky. Sometimes, usually, only one type works for the certain problem. Okay, now that is done, so let's try another example. This is going to be a little bit different from the last one. So let's take a look here. They want us to find the, well, they want us to calculate the double integral of this function, and they already told us the order of the integration. So that is good because we don't need to determine the type. So they determine this for us, and then they ask us to draw the domain region of this double integral. So let's take a look here. So here they sweep the x variable first, so which means that the function h1y here equal to 0, and that's equal to x, and h2y here, which is the function on the right hand side, that is equal to ln y, and that's equal to x value. Okay, because this is x equal to ln y and this is x equal to 0. So let's draw the domain region. What does it look like here? So we have to use this as the information to draw the graph. Alright, so let's draw the graph here. So we have one line, x equal to 0. Is this x equal to 0? Well, I'm gonna use the black here, x equal to 0. Now I take a look at this and I don't see how it looks like. I need to draw this graph. In this form it's kind of hard to see what it looks like, so what about I change this form a little bit. So this becomes, well, this becomes y equal to e to the power of x. So this is like exponential graph. So I'm going to draw this exponential. Okay, starting here and starting at 1, exponential, going up like that. Because when x equal to 0, y equal to 1. So we have this intersection right here. So this is the function on the left and the function on the right. So we have this black line. I'm going to make it more clear here. Alright, and this is the graph that we are looking at. We are supposed to find out the domain. Now, in order to find the boundary, the next boundary, we need to look at the y value. So we can see that the y value starts from 1 and ends at ln 8. So we are going to start at 1 right here and ends at ln 8. Ln 8. So, well, what about something like this? Okay, so we have this region. So our domain is going to look like this, and we are going to, in this case, as you can see, we are going to sweep the x variable first. So start from the left hand function to the right hand function, left hand function to the right hand, and go all the way through. Okay, so we got everything here. So let's start working on this one. So we have this integration, double integration, x start from 0 and ends at ln y, and y start at 1 and ends at ln 8, and we have this function e to the power of x plus y dx first and then dy. So let's start with the first one right here. Let's integrate this with respect to x. So when you integrate the exponential, nothing changes, right? So the result of this is e to the power of x plus y, just the same. Okay, and then you need to evaluate this at two values, x equal to 0 and x equal to ln y. And don't forget to integrate this another time with respect to y, starting from 1 to ln 8. Okay, now ln y goes in as x, so you have e to the power of ln y plus y minus e to the power of 0 plus y. Okay, and integrate that with respect to y. And y equal to 1 and ends at ln 8. Now, this is the first term here is I think it's kind of hard to see, so why don't we split it? So we have this e to the power of ln y times e to the power of y. Now the next term is e to the power of y, and then we need to integrate that with respect to y from 1 to ln 8. Okay, now we see the common terms, which is the e to the power of y, and then we have this e to the power of ln y minus 1 dy, integrate from 1 to ln 8. Well, when you see something like this, you are supposed to know that this is equal to y. Well, exponential of ln, well, it cancel each other, right? So it becomes y. So here we have this integration of e to the power of y and y minus 1 with respect to y start from 1 to ln 8. Alright, we need to integrate this, and you can see that this is not so straightforward because we have y here and we have y here. When it comes to differentiation, if you see this product, you are supposed to apply the product rule. But in the integration, when you see something like this, you are going to do this part by part, and that is the by-part integration. So apply by parts. Now for by parts, let's take a look at the formula here. So we have this integrate u dv is going to be equal to u dot v minus integrate v du. So in Cal 1, I told you that when it comes to choosing u and v, so you choose, you choose u, that is easier to differentiate. Choose u, that is easier to diff, and then you choose, oh, not y, not y, up here is supposed to be u. Okay, choose u, that is easier to diff, and then you choose dv, that is easier to integrate. So I look at this, I see one term, e to the power of y, and then I see another term, y minus 1. Which one is easier to integrate? Well, y minus 1 is not difficult to integrate, but it's not as easy as e to the power of y. So I'm going to choose dv here as the term that is easier to integrate, which is e to the power of y dy. Alright, and then I choose u to be y minus 1, the other term. Well, for differentiating, both terms are equally easy, but I'm going to stick with the one that is easier to integrate, which is e to the power of y. Alright, so this is what we have. So we are going to diff this u du with respect to y equal to 1, which means that du equal to dy. Now with this dv, we are going to integrate that dv with respect to integrate that dv, and we are going to do the same on the other side, integrate e to the power of y dy. Alright, and this is going to be equal to, well, integrate of dv becomes v. Integrate of e to the power of y, we have the same thing right here. Exponential doesn't change. So in the end, in order to apply the by parts, we need this dv, we need this u, we need this v, we need this du. Okay, let's put everything together and let's determine the answer for this. Okay, integrate u dv equal to u dot v minus integrate v du. So do we know u here? Yes, we do. Up here is y minus 1. Do we know v? Yes, we know it right here. We just found out v equal to e to the power of y. And this has to be evaluated at 1 and ln 8. Don't forget that. Sometimes you forget this term and you leave it to y minus 1 and e to the power of y. No, this is a definite integral. You are supposed to put in the boundary, the lower boundary and the upper boundary. Okay, and then we are supposed to continue with this integrate. V, do we know v? Yes, we found that. V is e to the power of y, and du is dy. Okay, this looks good to me. So this, we evaluate that ln 8 goes in as y, so this ln 8 minus 1 and e to the power of ln 8. Okay, and then minus 1 goes in, so this becomes 0. So this doesn't matter now, e to the power of 1. Alright, I forgot something. This integrate of e to the power of y, you are supposed to put the boundary, which is the 1 and ln 8. So this is the front terms right here, and then the back terms, that is the integration of e to the power of y. So I get the same thing, e to the power of y, and evaluate at 1 and ln 8. So here I have ln 8 minus 1, and that e to the power of ln 8 becomes 8. Okay, this goes to 0. Okay, and then minus ln 8 goes in, so e to the power of ln 8 minus e to the power of 1. Right, so we have here, so we have 8 ln 8 minus 8 minus 8 here plus e. So we have 8 ln 8 minus 16 plus e. Let me check the solution here whether the result I have here is correct. So 8 ln 8 minus 16 plus e. So this is correct. Well, this requires by parts, so don't forget you have to study about Cal 1 too. Don't throw everything away, because sometimes you need that for some of the problems here. So example 4 is done. This one is not so bad, because we don't need to determine the order of the integration. It's determined for us. The hard part of this example is that you have to use the by parts. And if some of you forgot about this, it can go quite confusing. It can get quite confusing. Okay, example 4 is done. And let's try example 5. Okay, example 5, what is it? We need to calculate the double integral of 16 minus x squared minus y squared over a region, over a domain. Well, it means that you look at this and you can tell that we don't know the order of the integration. It means that we need to find that out by ourselves. So let's take a look here. The region is enclosed by, the first line is y equal to 2 square root of x. Next line, y equal to 4x minus 2. And the next line is x-axis. So we need to know the type in order to continue. Otherwise, we don't know which formula to use. So let's draw this. So we have this graph. Okay, let's try the first one, y equal to 2 square root of x. Well, I'm going to make it a little bit longer so you can see. Let me delete that. Okay, maybe a little bit better. Alright, 2 of square root of x. Square root of x, this is like parabola on the side, so the scale I draw here might not be accurate, but I think it's enough. Okay, this is parabola that is quite steep. Okay, it's gonna look like this. Parabola on the side. Okay, that is the first line, and then the next line is this y equal to 4x minus 2. So this is a straight line with the slope of 4 and intersect y-axis at minus 2. So let's say that minus 2 is here, and this straight line is quite steep. So I would say that, oh, this is going to be hard to draw. Alright, maybe something like this. Oh. Okay, like that, straight line. Okay, alright, that is the second line, and then the next line is x-axis, so it's going to be this. So you can see that these 3 lines trapped a base, a region between them, and it looks like this. Okay, and we are supposed to do some sweeping in order to cover the whole region. So if it's up to me and I look at this region, I would choose to sweep this region horizontally, because to me I see this one function on the left hand side right here. This is the function on the left hand side, and I see another function right here on the right hand side. Okay, with this kind of looking, you can see that we can sweep from the left hand function all the way through to the right hand function and continue with that over the whole range. Okay, and let's put all these functions in. Y equal to 2 square root of x, and we have y equal to 4x minus 2 here. Okay, and before anything, let's find the intersection of the region here. So we have 2 intersections. One when the straight line intersect with the x-axis, and another when the straight line intersect with the parabola on the side. So let's find the intersection of these 2 intersections. So the first one, intersections, that's the first thing we are supposed to find. Well, if the problem gives you the graph, then you don't need to find, because sometimes they already told you what are these points. But since they didn't tell us, so which means that we are supposed to find that ourselves. So let's find the first intersection. The first one is x-axis, which is y equal to 0, and another line is 4x minus 2. So we need to solve 4x minus 2 equal to y. So we need to solve these 2 equations at the same time. So this we have 4x minus 2. Oh, okay. 4x minus 2 equal to 0. And from this, you can tell right away this x equal to 1 over 2. Well, you solve this equation, you get this. X equal to 1 over 2, it means that the coordinate at this point is 1 over 2, and of course this is on the x-axis, which means y equal to 0. Alright, so we got the first point. Now, the second intersection happens with 2 lines. One is y equal to 2 square root of x, and another line is 4x minus 2 equal to y. We need to solve this at the same time, so we substitute 2 square root x to the second equation. So we have this 4x minus 2 equal to 2 square root of x. Well, before anything, let's cancel the common terms. So we have this 2x minus 1 equal to square root of x. And we are going to solve this. Well, when you see square root like this, let's square both sides. So square the left hand side to get front square. 4x squared plus 2 front back, that is minus 4x plus back square equal to the other side square, x. But I want you to keep in mind that anytime you do something like this, square, it can give you trouble, because when you do square, sometimes the sign, the condition with the sign is omitted along the way. So when you do something like this, square both sides, and when you solve the equations, you are supposed to check all the answers you get, because sometimes the sum of the answers won't satisfy both equations. So let's do this. 4x squared minus 5x plus 1 equal to 0. So let's do factorization. I get 4x 1 and x 1. Combine this, I'm supposed to get minus 5x, so this 5 minus and this minus. And from this, I can see that the solution for this polynomial is x equal to 1 over 4 and 1. So we need to check both of them. Don't assume that both of them are correct, because we did something like this. We square both sides. Sometimes the sign can go wrong. Okay, so let's check the first one. X equal to 1 over 4. Let's put into the equation that we have. So y is going to be equal to 2 square root of 1 over 4. And that is equal to 1. And with this, let's try the second equation. Y equal to 4x minus 2, and we have 1 over 4 here minus 2. And it turns out here I have this minus 1. So you can see y equal to 1 here and y equal to minus 1 here. That's a problem, so this is not an answer. There is something wrong with the sign, and that is because we do this square thing here. So just get rid of this one, just cut the 1 over 4. This is not the solution. Now we need to try x equal to 1 too. Now let's try on the first equation, y equal to 2 of square root of 1, and that is 2. Now the next equation, y equal to 4, 1 minus 2, and that's 2. Okay, so this one is good. 2 and 2 is equal. So we can see that this coordinate happens at x equal to 1 and y equal to 2. Right? We got all the necessary points here. So we can start we can construct the formula in order to find the answer for this example. Okay. All right. What about I construct it right here? So we are going to integrate this 16 minus x squared minus y squared with respect to in this case with respect to x first, and then we are going to integrate this with respect to y. Okay, for the first integration, we are supposed to identify the left hand function and the right hand function. So here we are supposed to put in this h1y and h2y. We need to find that out, and for the integration with respect to y, we can see that the whole range starts from y equal to 0 to y equal to 2. So for this, sort of easy to find, this is 0 to 2. The whole range starts from y equal to 0 to y equal to 2. Now our job is to find h1y here and h2y. So h1y, that is the left-hand left-hand function, left, and this is right. So from the equation that is given, we know that the left-hand function is y equal to 2 square root of x, and some of you might say that this is going to be equal to h1y. This is wrong. You can't do that. This is not going to work because h1y has to be a function of y, right? You can't use 2 square root of x here. So we have to do something with this expression. So instead of leaving y equal to 2 square root of x, what about we switch things around? So we move 2 to the other side and we find out the x value. X value is going to be y over 2 square. So this is y over 2 over 4. Alright, so with this, now you can say that h1y is equal to y square over 4, and this can be used. Alright, sorry for the space. Okay, now h2y, that is the function on the right, and you can see that the function on the right is what? Is the straight line, right? So you can see that the function we have here is y equal to 4x minus 2, and don't do the same thing as what I just showed you before, which is to make this equal to h2y, because this h2y is supposed to be a function of y. So if you put it like this, this is on the left hand side is function of x, and this is function of y. So you are supposed to move things around. So this becomes x equal to, move 2 to the other side, y plus 2, and move 4 right here. Now this can be equal to h2y, and no problem here. Alright, let's continue with this. Now with the h1y and h2y, we can start with the integration now. So integration of 16 minus x squared minus y squared with respect to x first, and x start from the left hand function, which is y squared over 4, ends at the right hand function, which is y plus 2 over 4. And now we need to integrate this with respect to y, and y goes the whole range, starting from y equal to 0 and ends at y equal to 2. Alright, now we do the integration normally, like before. Start from the inside and go outside. From the inside, treat other variable as a constant. So this, integrate 16 with respect to x, 16x. Next is x cubed over 3 minus xy squared, and we need to evaluate this at two values, y squared over 4 and y plus 2 over 4. Now we need to integrate this again with respect to y, from y equal to 0 to 2. Alright, this is going to be messy. So we need to plug this y plus 2 over 4 and y squared over 4 in as x. So this becomes 16 times y plus 2 over 4 plus, so this is minus 1 over 3 times x cubed, right? So this x cubed is y plus 2 over 4 cube minus x, and in this case this x is equal to y plus 2 over 4 times y squared, and that is the first terms. this first term is supposed to be minus, repeat of that, but with y squared over 4. Y squared over 4 looking the same, and y squared over 4, and this times y squared. Right, with everything done, you are supposed to work this out, and then you have to integrate this again. Integrate this again with respect to y, and this starts from y equal to 0 to 2. And this is too messy for me to write it here. So if you work this out and you put this in a calculator, it's going to come out to be equal to about 12.4. Okay, and that is the sort of like the volume under this surface over this domain. Okay, so this is the answer for this example. But I want you to take a look at this. Let's save some space here. This is equal to 12.4, and I'm going to save this space. From up here, you can see that we see this. Let's take a look at the graph. We have this region, and we determined that we have one on the left and one on the right. But some of you might not agree with me. Some of you might say that, hey, I don't see that. I don't see one on the left and on the right. Instead, I see one at the upper and two at the lower. So let's take a look at that. I'm going to draw the same thing, same graph. Alright, I'm going to try to make it look the same. It's just so hard to draw on the tablet. I just don't know how you guys can do this. Alright, let me compare. Okay. Alright, so I have this graph over here, parabola on the side. I don't like that. Okay, what about this? Okay, this is better. And now I have this straight line, 4x minus 2. So it's supposed to cross the y-axis at minus 2. So maybe something here and that. Okay, so before we have this region and see one on the left and one on the right. But you don't agree with me, which I like. I like when people don't agree with me. So instead, here you see something on the top here, and then you see a line at the bottom, at the lower part of the region. So one is here, and another one, I'm going to use different color, is here. So with this kind of looking at this region, you can see that you can actually sweep this region vertically. Up here you sweep horizontally, right? So here you can decide to sweep this vertically. So this is going to sweep from the lower function, which you know this is x-axis, all the way here. But then if you use x-axis, you have to stop here, and then you are supposed to sweep again using different graph, because at this point in this region, the lower function is the green line, the straight line. So let's take a look here how we translate this into a formula. So let's draw this. This intersection is 1 over 2 and y equal to 0. And this intersection happens at x equal to what? 1 and 2. Alright. X equal to 1 and y equal to 2. So instead of doing just like what I did, you decided to do something more creative. I want to be different. So let's take a look here. In order to sweep the whole region, let's take a look at the first part. which is this part. Alright, let's sweep it. So we are going to sweep the y variable first. You can see that this is vertical sweeping. So we sweep y variable first. So this is 16 minus x squared minus y squared with respect to y. So we are going to sweep from y, from this lower function, which is y equal to 0. Y equal to 0. To the upper function, which is the red line here. This is y equal to 2 square root of x. So this is y equal to 2 square root of x. And now we sweep the x variable. Now we sweep the x variable over the whole range, and you can see that this part has the x variable starting from 0 to 1 over 2. We are looking at just this part. So for this chunk, x starts from 0 and ends at 1 over 2. And that is only the first part. We haven't included everything, so we have to include the second part, which is the sort of the same thing, double integration, which sweep the y variable first. But in this second part right here, I wish you understand this. Not I wish you understand this, but the graph here is a little bit messy, so I'm afraid that you might not see what I see here. So I think you can see both sides, right? One with the straight line x-axis at the bottom, and the other with the slanted line at the bottom. So with this second part, you have this lower function as the green line, and that is y equal to 4x minus 2. So that is the lower function, y equal to 4x minus 2. And the upper function is the same thing, y equal to 2 square root of x. Right? And then we have to integrate over the whole range of x for this second part. So you can see that this range of x start from x equal to 1 over 2, right? At this point, 1 over 2, and ends right here at x equal to 1. Okay? So if you decide to be creative, to be different, in order to find this solution for this problem, you have to do the double integral twice. So it's up to you. I don't mind if you go this way, but if you have a way that, if you know that this way, this way up here requires one double integration, I think it's going to save time doing the one integration instead of doing the two double integrations like this. But if you decide to work on this and you get the numbers right, it should come out to be just the same. It should be equal to 12.4, because we sweep the whole region just the same as the first way that we did right here. Okay, and that is example 5. What about I end it right here? I think it's getting long, so in the next video I'm going to explain to you about example 6 and example 7.